In the 17 and 1800s, more and more elements were being discovered. But how to organize all of them? Well, that's what we are going to look at in this video. Be able to define periodic law, metal, nonmetal, and metalloid. A word of caution, metal, nonmetal, and metalloid are things we are going to work on in class, so we are going to define those in class. Be able to relate the periodic table to the outermost energy levels of atoms. This will require you to look back at a previous topic. Predict an element's reactivity based on the group it belongs to in the periodic table. This will be a goal for this entire chapter. Compare groups in the periodic table. Again, we'll start today and work through our chapter. And relate Mendeleev's periodic table to the scientific method. In 1829, J.W. Dobereiner published a classification system of elements where he organized them into triads. These triads would have similar characteristics to one another, with the middle element being somewhat between the other two elements. Mendeleev realized that it was more than just three elements in a row. He organized them into columns and found out that with increasing mass down the column, you could see increasing reactivity or different properties of the elements changing as you went down a column. Not only did Mendeleev create this system of organizing elements by mass, but another scientist in Germany did very similar. Now, Mendeleev actually had a hypothesis, and his hypothesis was that missing elements would have characteristics that were intermediate between other elements above and below them on his periodic table. So this hypothesis could be experimentally tested, and after a time, it was. As germanium and gallium were discovered, it was found that they had characteristics between zinc and arsenic. So these elements had intermediate characteristics, as was predicted by Mendeleev's periodic table. So this supported his hypothesis, and this supported his concept of a periodic table, thus using the scientific method to support the periodic table. Periodic law is a relatively simple concept. When you have elements organized by increasing atomic mass or atomic number, which is number of protons here, you're going to have a periodic repetition of physical and chemical properties. This is why this is called the periodic table, because over time you're going to have this periodic repetition of elements. In class, we're going to watch this little YouTube video about the alkali metals, showing that they have increasing reactivity as they have increasing mass. Here we have metals, metalloids, and non-metals in a periodic table. The metals are going to be good conductors, and they're going to conduct heat very well, and they're going to conduct electric current very well. They're shiny, usually, when they're freshly cut, and they react well with halogens. Non-metals are not going to be good conductors of heat, and they're not going to be good conductors of electric current. One exception, of course, is going to be graphite, which is a great conductor of heat. They tend to be kind of brittle, so if you whack on them with a hammer, they're going to shatter. Metalloids, as the name might suggest, are kind of intermediate between metals and non-metals. So they're semiconductors, meaning that they are able to conduct electricity well given certain circumstances. This is what makes them very useful in computers.